Hey folks, welcome to the channel. If you're new, I'm Thomas. I am actually now a second year PhD student in astrophysics at Cardiff University, and this is going to be a bit of a different video to normal, something new I'm trying, where I just want to sort of have a chat with you. I've got a cup of tea, and we're going to today talk a bit about the first year of my PhD, what it's been like, how I found it, challenges I've had, and then sort of round out with like what's coming next and a bit of advice for anyone who's starting out their PhD. So there'll be chapter markers along the bottom of the screen. So please jump to any sections that you're most interested in. But if you just want to listen to all of it, then let's get started. So, like I said, I'm Thomas. I am a PhD student in astrophysics. I'm from Scotland. That's where I did my undergrad. I did my undergrad at St Andrews, and now I am at Cardiff. Now, my PhD, it is in galaxy simulations. Specifically, I'm looking at the evolution of galaxies and something called the circumgalactic medium. It's kind of like an atmosphere around galaxies that mediates like any gas going in or coming out, and it's really important for the evolution of galaxies. If it didn't exist, there'd be no way for galaxies to bring in gas to form more stars, and stars like our sun might not exist. So it's a pretty important thing to understand, and currently we don't. It's really hard to observe. Like, trying to observe it with a telescope is incredibly difficult because it's really, really underdense. You don't really get it in emission. Normally you see it like as it blocks out other light. So what we do is we follow it in simulations. We like apply the laws of physics informed by the observations we do have to sort of try and understand how it evolves over time and how different things affect it. So that's what my PhD is about. Though I realise I should probably cover what actually is a PhD and how are PhDs in the UK. That was a brilliant sentence, I know. So PhD, it stands for Doctor of Philosophy. Yes, it's the wrong way around. And yes, I'm doing it in astrophysics. I'm not a philosopher. I don't study philosophy. It's just what the qualification is called. And that's great. It's a research degree. So if you've done, say, an undergraduate degree, you know that you'll go to lectures, you'll have labs, you'll do exams and all that sort of thing, or whatever you do in the humanities that I don't really know that much about. But anyway, an undergraduate degree is taught, and then you get master's degrees. So you might have heard of things like an MSc, Master of Science, and that's typically a taught course as well. So you go to lectures, do labs, do experiments, do exams, and get a grade at the end of it. PhD is a bit different. Rather than having lectures and labs and doing experiments and doing exams and getting a grade at the end of it, you do research. This is why if you're in universities, you'll hear PhD students being referred to as PGRs, postgraduate research. And that's really important. So doing a PhD is learning to become an independent researcher, and you do it by learning on the job. So rather than doing exams, having lectures, having labs and all that stuff and getting a final grade, you start off with a project. Now, your project is normally defined by your supervisor, an academic whose entire job, as far as you're concerned, is to provide advice, to supervise your PhD progression, and to make sure you're getting the training that you need to get the degree. So they typically define the project, the broad topic, and they might start you off on your first thing, and then you just do it. You read papers, you try things out, you do experiments, you, in my case, run simulations, and in the end of it, you write papers, and right at the end of the PhD, you write a thesis. This is a 100-page-ish document of everything you've done over 3.5 to 4 years in the UK system. Everything I'm saying in this video relates to the UK system. It does not relate to Europe or the US or anywhere else. This is the UK system where PhDs take 3.5 to 4 years, depending on your funding situation, and you write a thesis at the end of it. In a typical UK PhD, you don't have to do modules, you don't have to do labs, you don't have to write essays and sit exams. You don't have to do any of that. The whole thing is research. However, my PhD is not a typical PhD. My PhD is part of something called a Centre for Doctoral Training. This is kind of like an add-on to the PhD that gives you specialised training in a given topic related to that CDT. So you might get a CDT in condensed matter physics, and you'll get a load of modules in your first year that specifically train you to be really, really specialised at condensed matter physics. My CDT is focused on AI, machine learning, and advanced computing. These are a lot of buzzwords, and I do not do all of them. So I don't really do anything with artificial intelligence. I don't really do anything with the subset of artificial intelligence that is machine learning, and I do quite a lot of advanced computing, specifically working with big data, but we'll get onto that. So my PhD is part of the CDT, and we have a load of modules in the first year on things like data analysis, machine learning, data visualization, stuff like that. So a bit of background. I told you before I'm Scottish. You may have got that from the accent anyway. I did my undergraduate degree at the University of St Andrews, and there I studied astrophysics to a master's level, all as one degree, and I did my master's project in star formation simulations. There's plenty of stuff on this channel all about that. I'm not going to dwell on that any further. My PhD is at Cardiff University. I got my offer in, I think it was like May or early June 2023. Bear in mind I was starting in October. So I had to move to Wales. Now, if you're not really familiar with geography of the UK, that's about 400 miles away. And while 400 miles might not sound a lot to people in the US, in 400 miles, the name of bread rolls changes about 7 times. You've gone through about 15,000 different accents, and everything is very different. So I moved to Wales. My partner moved with me. Now I live in Cardiff. We're renting this house that I've been in for the last year, and honestly, it's really nice having a room this big to work in. Like, my desk is over there that I do all my work at. This is just another table I've pulled in for this video. My bookcase is over there, and I've got this sort of storage behind here. There's a sofa bed over there. But there's still enough space in this room for lights. There, microphones. Like, it's so nice to have this much space just dedicated to work for a PhD and to content creation. I decided to make this video now because we are 1 year in. 1 year ago, I was starting out in a brand new department in a country in the UK I had essentially no friends in a topic that I didn't know anything about. So starting out was a big adjustment. I am not the most sociable person. I think that would be a fair statement. I am not the most sociable person by any stretch of the imagination. And I did find it a bit tricky starting out in this new department with people that I didn't know in a city that I don't know very well. It took some time to sort of really make some friends here. Thankfully, I feel like I'm now really making friends in Cardiff, which is a nice experience. Makes it a lot better. Though I will say right now that I am very glad I had my partner to move down with me. It made life a lot easier. So thank you. Anyway, let's move on. Let's talk about research. Like I said, I was going into a new field, going into galaxy evolution, going into the circumgalactic medium. And the first few months were very much right, how do I do this? I had to learn a lot. Going into the PhD, I knew essentially nothing about galaxies. I'd gone full on star formation right through my undergrad, and I didn't really think I was going to do galaxies in my PhD. I'd applied for a load of star formation PhDs, and then realised that because I was looking at simulations, I would be doing essentially the same work if I looked at galaxy simulations. It opened up a whole load of options for me, and thankfully it's the offer I got. I only got one, and it was this one. Thankfully it was a good choice. So the first few months were a lot of learning, a lot of reading, papers, quite a lot of reading textbooks, trying to sort of get a grounding in this field that I had largely ignored for 5 years. I'd done a very small amount on galaxies in my undergrad, and yeah, I had a lot of catching up to do. Thankfully, I'm kind of caught up for the most part, at least as far as I need to know for the PhD, for my area that I'm doing my PhD in. So that's good, but it was a bit of a slog getting to grips with the literature, getting to grips with how we do the work. So I said we use simulations. So for those who are really interested, we use cosmological zoom-in simulations of galaxies simulated from redshift 127 up to redshift 0, which is the present day. 13.8 billion years of simulating a galaxy to see how it evolves, but we can only really say that we are happy with how it evolves from about 5 billion years ago up to the present day, because there are certain assumptions we make in the early universe because we wanted the simulations to be accurate in the present day, and not to take ridiculous amounts of time to run. So these simulations, they are, I will talk more about how we do our simulations, what we do our simulations in at some point. Suffice it to say, they were new to me. Everything I'd done before was kind of small scale, could run it on like a couple of dozen CPU cores, and it would take like 3 days. These simulations take more like 3 months on like 5,000 CPU cores. These are huge simulations. They generate a ridiculous amount of data. So I had to get very good at working with very large quantities of data in Python. Now, I've talked previously about coding in astrophysics. There's a recent video on that. A lot of data analysis is done in physics in Python. It's a programming language. It's very approachable. And I'd used it before. I just hadn't used it that extensively. I've used more Python in the last year than I've ever used before. And I had to get to grips with some new tools, some new modules and such. And that took some time. And then there was the one big early setback for me. So I mentioned before that PhD supervisors will typically have like an idea of the first thing they want you to do. Now, either this is something they've had sort of kicking around, oh, I could do this, and it's kind of a self-contained project in itself, and it's a thing to start on. So my first thing that I was given to do was something on thermal conduction, and we started off doing some stuff with this. I started having a look at various things, and then we discovered there was some problems with those simulations, and we parked that in December, so like 3 months into the PhD. And we're like, right, we'll come back to that when the simulation code is better for that sort of thing. So we parked that after I'd done like 2 or 3 months on it, and we're like, right, what am I going to do now? Fortunately, I had been kind of combing through a few different simulations, having a look at some stuff, visualizing things, and I noticed there was some differences between some simulations with magnetic fields and without magnetic fields, and that's kind of what I've spent the rest of my first year of my PhD working on, is this project to do with satellite galaxies and magnetic fields. And I'm not going to say much more about the science of it just now, because I know not everyone's going to be interested in that. There will be a video on the channel in a few months' time when I've published the paper on that. About the same time, there was a conference that came up that was happening in Vienna, in Austria, in February. I made a vlog when I went. It's on the channel, and obviously going to Vienna, it's a long way to go. Like, it was 2 flights connecting like Cardiff, Amsterdam, Vienna. Week-long conference, was going to use up a good amount of my travel budget. So we kind of took the mentality of, well, it would be nice to present something, even if it's still a work in progress. And the way you do that is with a poster. Posters are kind of like the gateway drug to academic presenting, so like they're very easy to do. They are normally A1 or A0 size, which is pretty big, but they only need maybe 3 or 4 figures and a small amount of text. You don't have to spend ages developing like a 15-minute long presentation. You don't have to stand up in front of a room of 150 astronomers and say, hi, this is what I'm doing and this is why you should care about it. And yeah, it's one of those things that's very easy to do within academic presenting, so it's why a lot of PhD students do it for their first or even their second or third conference, particularly if those conferences are like oversubscribed and they can't get a slot for a talk. So yeah, that's what I did. I made an A0 poster and I took it to Vienna and I presented it at this conference with like 150 other astronomers. It was really, really fun. It was essentially a really, really intense week of listening to talks by the leading people in the galaxy simulations field and then getting to talk to them about what I do. It was really, really fun. And it was the first big bit of travel that I'd got to do as part of my PhD. I mean, it wasn't the only travel that I did in my first year. Like I said before, I'm part of a Centre for Doctoral Training. And anyone who's watching this who's part of a CDT might be wondering, why am I talking about travel and a CDT? Because most CDTs sit within one department, or at least one like university. My one doesn't. My CDT, however, is split over 5 universities. Cardiff, obviously, Swansea, who kind of organised the whole thing, it's run out of Swansea University, Aberystwyth University in the west of Wales, Bangor University in North Wales, and Bristol University, which is in the southwest of England. So it's spread over 5 universities, and throughout the first year we have training events at each of the university towns. So we had an event in Cardiff, we had an event in Swansea, we had an event in Aberystwyth, in Bangor, and in Bristol, and it was really nice to see different bits of Wales and Southwest England, but also to meet up with the other people in my PhD cohort in the CDT, because we're all doing different things at different universities. We're not all astrophysicists. There's people in machine learning, in bioinformatics, in particle physics, in other people in astrophysics, obviously. And it's great to meet up with them and see how are they getting on, what are they up to, and commiserate about challenges we're having. So looking ahead into year 2 and beyond, I am at the point where I'm writing my first paper. This project to do with satellite galaxies and magnetic fields is nearly finished. We have got figures, captions are just about done, and I'm in the process of writing it. I've written my methods section, most of my introduction section, still got to write up the results and discussion and such. But what I'm hoping is that by the end of 2024, so within the next 3 months, I will have a paper draft, something that is written about the work that I've been doing and, with a bit of tweaking, could be submitted to an academic journal to be published and shared with everyone. And when I do that, I will make a video about it. I'm just not really going to promise a timeline on that. Subscribe, you'll get it eventually. Going into second year is obviously that, but because we're now in the write-up stage, I'm starting work on future projects. So I already mentioned thermal conduction. We're now at the point where we can kind of start thinking about actually putting in proposals for computer time to actually do that project that we wanted to do but stalled. And then looking a bit beyond that, with my CDT, I am required to take 6 months out of my PhD to do an industry placement. Something that I think a lot of people think, and that maybe I thought at some point, was that everyone who does a PhD stays in academia long term, becomes a researcher, becomes a lecturer, a professor eventually. And that is definitely not true. There are not enough postdoctoral positions. That's the bit that comes after PhD. There's not enough postdoc positions for everyone who does a PhD to have one. A lot of people who do a PhD go out into industry afterwards. And one of the things that can be a problem is that you can be viewed as being too specialised, particularly if you've, say, done a PhD in astrophysics. There aren't that many industry jobs in astrophysics. You've got to go and do something else, like data analysis or finance or something else kind of data analytics-y. That's definitely a word. With my CDT, I get all this training and things like AI, machine learning and such, but also I get this industry placement where I go and do something in a company or an academic adjacent industry where I get practical on-the-job experience in things like data analysis or software engineering or something else like that would make me more employable if I don't stay in academia after the PhD. So that'll happen a year from now, so the start of the 3rd year, and I don't yet know what my placement's going to be. I'm hoping for something good, but we'll see. And yeah, my first year has been great. I had to take some time to learn the stuff, really find my footing in the field. It's taken time to get to know people. There were times where I was kind of struggling with being a bit sort of lonely, missing friends from back home. It's got easier because I've spent a year with these people in the department. I'm finally getting to know them. Everyone's sort of opening up a bit more. So yeah, we're in a good place. And I'm really excited for the next year. I'm really excited to try some new things. I'm really excited to get this paper published. And this may sound like the end of the video, and it's not. I've got a bit more to talk about. What I want to do now is kind of talk directly to people who may be watching this in the position I was in a year ago. People who are just starting their PhDs, or even people who are thinking they might apply for PhDs in the next few months for starting this time next year. Everyone kind of always asks the same questions on these things. So let's go with some frequently asked questions and my advice for them. Everyone's PhD journey is different. Mine will be different from yours. It's different from everyone else in my department. It's different from every other PhD student in the country and in the world. Everybody's PhD journey is different. Everyone makes progress at different speeds. And it's not a reflection on anybody. Somebody who gets a paper out in their first year isn't necessarily a better PhD student or a better researcher than somebody who doesn't publish until year 3, doesn't publish at all. Everyone's project is different. Within my astrophysics PhD cohort in Cardiff, we have one guy who is in the process of getting his paper published. He's put it out to collaborators and is getting feedback, and they're making changes to actually submit the thing. I have barely started writing mine. I've still got a long way to go to get to that point. And then there's people who are just like, well, I can't write a paper yet. I don't have anything to write a paper on. And that's normal. I think that there's really like two categories of people who get papers out within the first year of their PhD. And they're either people who work, actually it's three categories. People who work way, way, way too much in the first year. They will be the ones that will burn out and may not even finish. Then you've got people who've got a project that's very defined, very well defined and very constrained that the supervisors come up with. So they've given them something that can't sprawl too much, that it's easy to write a very straightforward paper on. Or they're joining a group where there's been a previous PhD student or previous postdoc that's worked on this topic before, worked on some project and has never finished it. So the literature is already collected, a lot of the work could already be done, maybe simulations have been run, and it's primarily the analysis that needs done. These are the people that get papers out in their first year. Most people don't. The vast majority of people don't. In fact, it's very normal to not publish until year 2, year 3, or maybe even right at the end or after you've submitted your thesis. So don't go in expecting to have published a paper in your first year. If you don't go in expecting it, you're not going to be disappointed. My next bit of advice for first year PhD students is read. A lot. Read things that your supervisor sends you. Read preprint papers. So if you're in the sciences, look on arXiv. If you're at least in physics, this is like where people publish papers before they go to a journal. Like it's not been peer reviewed yet, or it's like a free way to look at these papers. You can get an email every day if you're in certain fields with like the new papers in your field. Like it gets emailed to you every single day. You can just scroll down and think, oh, that's interesting, that's interesting, that's interesting, and end up with 130 Chrome tabs like I have. But read a lot, because if you read more, you'll understand more, you'll make those connections in the back of your head where you like now intrinsically understand things. Read a lot in your first year. You will thank me later when you come to write an introduction for a paper or your thesis down the line. And kind of along that sort of thing of trying to give yourself a sort of solid basis, like ask for help. Ask for help a lot. Ask for help often and early. Like give things a good go. But if you don't understand something, don't spend a month trying to figure it out. If your supervisor might know, ask your supervisor. If they don't know, then you can spend a month trying to figure it out. And the last bit of advice that I think I can give you is that, like I said, everyone progresses at a different speed. But if you get to sort of 3 to 6 months in and you still don't feel like things are making sense and that you still don't really understand what's going on, don't worry. That's entirely normal. We all feel that way. And yeah, that's kind of all the main bits of advice that I think I can give you right now, just off the top of my head. Ask questions in the comment section down below because I'm happy to answer them. I will be checking those comments. And yeah, this is the end of the video, by the way. So thank you for watching this video, like genuinely all the way to the end. I quite liked having this sort of chatty feel. I quite like the set. Like, I like having the table here. I like having the laptop. If you like this, do let me know because I could do more videos like this. Though it's going to mean bringing this table up and down the stairs all the time. We'll deal with it. Let me know if you like this. Let me know if you don't. And yeah, thank you all for watching. Subscribe, like, join the Discord community. You can ask questions there as well. Links are all in the description down below. If you're looking for something else to watch, then why don't you have a look at that video all about coding? Thank you very much for watching all the way to the end. And I'll see you in the next one.